Okay, guys, welcome back to part 2 of our next module, module 6, where we're talking about the lower appendicular skeleton. We are just going to start with the femur. So the femur is, let me see, I'm going to just grab the humerus. So remember we talked about the humerus, right? This was your upper arm bone, and then your femur is your lower or your upper leg bone. Let's get them both on the screen. So you're going to see more similarities. These two are analogous. Again, in a quadruped, they're going to do very similar functions. In humans, where we're bipedal, we're going to see some differences in sort of the robustness. Obviously, the size and robustness of some of the landmarks are going to be much bigger in the femur than they are on the humerus, because we don't have to bear any weight on this bone. But again, they are similar, or they serve similar functions, especially in quadrupeds. Okay, so we're always going to take things from the proximal to the distal. So proximal meaning closest to the actual trunk or like main portion of the body. So your proximal is going to be your hip joint, your distal is going to be your knee. So we start on the proximal end, and your femur starts, pictures of your femur starts on page 258 in your book. It's always a good idea to have that out while we're going through. So your femur is another beautiful ball and socket joint. We find our acetabulum on our hip, right? And these two roll around, right? So our hip has, again, that sort of beautiful 360-degree motion. Whereas like our elbow or our knee joint is just a flexion and protraction, right? Flexion, just to protract, and then extension. Flexion and extension. This is a ball and socket, so there's a lot more movement. So the head of the femur is sort of the ball part of that ball and socket joint. So this is the head of your femur. That's the first landmark that you have. So the femur only has one neck, unlike our humerus, which has two. We just have one neck, right? So this would make sense if we looked at this. This is the head, and this is the neck. Okay, so the head and the neck. Okay? And next we have a term called the Fovea Capitus. So anytime you guys see capitus, capitate, like that cap sort of thing, think about the head, right? Because if we take somebody's head off, we decapitate. So we remove the cap, which is the head. So Fovea Capitus, if we look at the head, we see a fovea right there, a fovea in the head. Fovea Capitus literally means fovea in the head. Okay? So head, neck, Fovea Capitus. We have two trochanters. So tubercles, trochanters are interchangeable terms. They're sort of big bumps. So trochanters. So remember the difference in the humerus, right? What did we have on the humerus? We had a greater and lesser tubercle. We're going to have a greater and lesser trochanter in the femur. So this big one here is our greater trochanter. And then we have this one here, which is our lesser trochanter. So greater trochanter and lesser trochanter. And you can see how everything in the femur is just bigger and more pronounced because we bear our body weight there. Okay, so the next term that we have is our intertrochanteric crest. That is a mouthful. Intertrochanteric crest. Oh, yep. And in your book, they're calling it the intertrochanteric line. The intertrochanteric line and crest are, it's fine. We can use either one. In our term sheet, we're going to use crest. So we're going to look between the two trochanters, right? Because it's intertrochanteric, which breaks down. Again, I think it's really important to break down the words because it helps you understand where these things are. So inter means between, trochanteric, the trochanters. So in between the trochanters, we have a crest. Okay? So anatomists are always going to name things, not always, because sometimes we have some weird things that pop up, but typically are going to name things for where they are or what they do. So this is the crest. It's in between. It's intertrochanteric, and it's a crest. Okay. Gluteal tuberosity. Okay, so let's see if we have a nice picture of that. Yes, we do. On 260, you guys find a nice picture of the gluteal tuberosity. So, again, gluteal. So we're looking at the posterior side of this bone. So your two big trochanters are on the posterior side. So, just trying to see. There's right here. Can I get a better light? So there's a roughened area right here. So you can see it in your book. It's not going to look super pronounced on this bone because it's a cast, and that's always a challenge. So we have our gluteal tuberosity. So what do we think attaches there? Our glutes. So part of our glute muscles, or our butt muscles, our glutes attach there. So remember back to the humerus, we had a deltoid tuberosity, right? That attached in basically the same area. So that first, like, upper third. So that's your gluteal tuberosity. So similar, again, because we're bipeds, our deltoid muscle is much smaller than our glutes, but they perform similar actions on our bones. So that is your gluteal tuberosity. Your spiral line. You know what? It's really hard to see with, even in person, it's a really, really hard landmark to see. I'm going to try it though, because we do actually have a really nice picture of it on 262. So if you look at your lesser trochanter, okay, and it's very, very faint. I'm trying to see if I can get a good light refraction. You guys can see it. There is, I'm drawing my finger on it. You guys might not be able to see it, but your book has a really nice picture of it. This is called our spiral line. So it goes from our lesser trochanter sort of around its spirals. Okay? It's your spiral line. All right. Medial and lateral condyles. So now we're going to look at the distal end. We're looking at the knee joint. So let's go to the knee joint in your book. Okay. It's going to show you from this end. I should actually see if there's a picture from the front. There's a picture of this side. So if you're looking at, so these are the two bumps, okay? You get some weird pictures, all of the really good ones showing you from the posterior side, but what I want to look at is look at the front, or the anterior side. So we know, obviously, that the ball and socket joint, the head of the femur, has to be medial, right? Because otherwise, what's it doing? Something weird is happening at your hip joint. So if we look at the condyles, there's two condyles at the bottom. This big, robust one sits right under the head. So the bigger of the two is going to be the medial, okay? It's your medial condyle, and then the outside of it is your lateral condyle, okay? So medial is bigger, and then the lateral is smaller. We have an intercondylar fossa, so that's going to be that depression on the back of the knee, okay? So you have like ligaments and tendons that work your knee joint that kind of run through this area, okay? So that is on the posterior side of the bone. On the anterior side, you have your patellar surface. Let me grab a patella. Okay, so your patella is your actual little knee bone. It sits right on there. Is that? Yes. So it sits right in there. Okay, that's your patellar surface. So it's going to be on the front, obviously, the anterior side. So you see that smooth surface. On the anterior is your patellar surface. On the posterior is the fossa, the intercondylar. So in between condyles, intercondylar fossa. And then on the front is your patellar surface. Okay, so if you've ever heard of somebody had an anterior cruciate ligament, it's the ligament that attaches sort of this part of your knee to the top of your tibia. Okay, so if somebody gets hit like sideways, it can tear those cruciate ligaments because this knee joint is designed to move in this direction, right? It's not a ball and socket joint. It just moves this way, flexion and extension. So if you get moved sideways, that's not great. You also have your lateral ligaments. So you have some ligaments that are going to just go, see if I can get this to balance. They're going to go from here to here. And then you have your cruciate ligaments that are kind of go from front to back. And those help keep this stable, right? Because you don't want this. This is bad. So if you've heard of somebody tearing their cruciate ligaments, that's usually the reason. And it happens in some dogs a lot too. They have to have cruciate surgery. You don't want to see this movement, okay? So like football, where you're getting tackled, and like you don't want to ever see that guy get tackled from the side where they take him out at the knees, because if those knees do this, it's really bad. It's not good. So that's a tear, and that is really hard to heal because you bear so much of your weight in your knee joint. Okay, so this little patella, what the heck is that for? The patella is actually I'm trying to balance this all together. When it sits here, it actually sits sort of, it's enveloped on either side with cartilage. So if you were to grab that patella, you could probably move it around a little bit within that joint. It actually, even though it's such a tiny little bone, it helps to distribute the weight. It makes that joint stronger so that you can bear that body weight. So patellas in humans are huge compared to other animals because it helps to bear so much of that body weight. Another cool thing about the femur is if you just found a femur, even if it was small, I'm just going to tilt this camera so you can see. Okay, so I'm going to tilt that. I'm standing it up, okay, on the knee joint. This is standing on the two condyles. Okay, so if you were to find a femur, even if it was a small one, you can do this. Go ahead and stand it on those condyles. And I'm just going to flip the camera again. So it's here. So standing here, flat, you can see that this hip joint, or this, this femur moves out at an angle, right? It's not straight up and down. Okay, it moves out to the side. Okay, can you see this? So if it was straight up and down, it would look like this. Okay, but in humans, the femur moves this way. Right? So the head of the femur, where the pelvis is here, and then the femurs move when we move distally towards each other, right? Because if you came just straight up and down, you would walk very bow-legged, right? You would have to move from side to side. So if you think about if you've ever seen like a chimpanzee stand on two legs and try to walk, it's not a fluid motion, right? They kind of sway from side to side because their hip joints are straight. So in a quadruped, instead of this angle, you would see this bone being straight up and down because they are going to bear their body weight down, right? So their hip is going to be, their back is going to be this way, and this bone is just going to be doing this. On humans, we go out to the side. That's called a carrying angle, right? Because we need to carry our weight from our hips down to our knees. And our knees need to be closer to the midline of our bodies. So that's hugely important for bipeds, right? So the tops of those femurs, the heads, are out here. As we move down towards those condyles, or that distal end, they move in. So that our knees, if we were to stand upright, they would be closer to our midline. that angle is called the carrying angle. So in humans, you'll see that. So if you find a femur and you stand it here on its condyles, if it's moving way out to the side, that's a human. If it's straight up and down, it's an animal bone of some kind. So that's good for you guys to know if you're ever in the position as a detective in a crime scene, again, in forensics, that if you find remains or somebody calls you and says, oh, I found remains, they might be human, those are some easy tests that you can do right off the bat to see if that femur is human. That carrying angle, again, straight up and down is going to be an animal or a quadruped, and an outward angle, like that, a carrying angle where it moves, right, the head moves out, is going to be a human. All right, so that's the femur. Your patella. All right, so let's talk a little bit about the patella. Patella is going to be here on 270. 270. Okay, so there's not a lot going on with the patella. It's just this little bone, but again, it's crucially important for us as bipeds. Okay, so our patellar, we're going to have two surfaces on the back where it articulates. Okay, so we have a lateral articular surface and a medial articular surface. Okay, so that sits in there. The medial articular surface is going to be the back that articulates more with the medial condyle, and then the lateral articular surface articulates with the lateral condyle. So those are on the posterior side. And the posterior side is very smooth. There's not a lot going on. You can see how smooth that is. And the reason, with other bones when we have articular surfaces, it's very rough. The patella, again, is sort of sitting or encased in a lot of cartilage, right? So it's very smooth. It's a very fluid joint. So on the back side, we have the medial and lateral articular surface. We have the apex. So the apex is going to be the point. The point always points down, the apex. And I think that's it for the patella. So I'm going to end this video here. This is the end of part 2 for the femur and the patella.